Hi students and friends, this is your host and teacher, Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. So I'll continue my O-level past papers and I was doing IGCSE 0620 and I'm done till question number 4 of paper 43 and it's of October-November 2024. So I'll continue from question number 5. So here's question number 5. This question is about rate of reaction and equilibrium. The student investigates the rate of decomposition of aqueous hydrogen peroxide H2O2 using manganese 4 oxide as a catalyst. The equation for the reaction is shown. Here's the reaction equation. 2H2O2 aqueous gives 2H2O liquid plus O2 gas. The student uses the apparatus shown in figure 5.1. You look at the figure, we have balance here, aqueous hydrogen peroxide in the conical flask with aqueous hydrogen peroxide loosely fitting cotton wool. And then we are also having manganese 4 oxide, which is a catalyst in a small container beside this conical flask. The student adds a catalyst to the aqueous hydrogen peroxide, replaces a container on the balance, starts a stopwatch, records the mass at regular time intervals. A. Table 5.1 shows the mass recorded at regular time intervals. This is table 5.1. You see the mass at regular time intervals, the mass recorded. Part 1 suggests why the mass decreases as time increases. If you look at the equation, during this reaction, the gas is released, which is O2 gas. So, O2 gas escapes from the flask. Part 2, after a certain time, the reaction stops. Explain why the reaction stops. So definitely all the H2O2 has decomposed or reacted. So you write all the hydrogen peroxide has reacted or decomposed. You see the reaction is decomposition because it's breaking down into two products, water and oxygen. Moving to next part, which is part 3. Suggest why it is not possible to use the results in table 5.1 to determine the exact time when the reaction stops. So if you look at this, if you see this, that you see the time interval, it is large. There will be time intervals too large. That's why we can't use the results. These results can't be used to determine the exact time when the reaction stops. B. Figure 5.2 shows a graph of the mass against time. So here's the graph of the mass. The experiment is repeated at a higher temperature. All other conditions remain the same. Number 1, explain in terms of collision theory why the rate of reaction is higher at higher temperature. Now they have already mentioned that the rate is higher at higher temperature. And you have to explain, in terms of collision theory. It's of 3 marks. So you can't write the statement rate of reaction increased or rate of the reaction is higher. So you will start with the kinetic energy of particles. The kinetic energy of particles increases. Kinetic energy of particles increases. Now, what else you can write? Now you refer to the proportion, fraction, or percentage of particles and include the statement higher proportion, higher fraction, higher number, or higher percentage of particles. They have energy greater than or equal to activation energy. Higher number, fractions. You can even write fractions. You can even write proportions. Or you can even write percentage of particles have energy greater than or equal to activation energy. Equal to activation energy. Activation energy is represented by capital E with the base A. You will get 2 marks here. 1 mark for this one, 1 mark for this statement. You have to add one more statement. Now there will be higher number of particles having energy greater than or equal to the activation energy. The frequency of collision, it will increase. So you write frequency of collisions between particles increases. Of collisions between particles increases. Moving to next part. Part 2 on figure 5.2, sketch the line expected when the experiment is repeated at a higher temperature. Now you have raised the temperature. So definitely it will only increase the rate of the reaction. The total loss in mass will remain same. But what will happen to the graph? So the graph, I'm using the different color here. So the graph, it will definitely start at same mass. Graph starts at same mass, but steeper gradient. But steeper gradient. What else? The graph, it ends or level off at the same mass but earlier. Graph ends or level off at the same mass but earlier. So I will start from 0, but will have steeper gradient, means it will be like that. See, it's leveling off earlier. Must be like that. Moving to next part. C. Manganese 4 oxide is the catalyst in this reaction. 1. Explain the meaning of 4 in manganese 4 oxide. This number 4 is oxidation number of Mn. Oxidation number of Mn, that is plus 4. Oxidation number of Mn is plus 4. Don't just write 4. You have to write the charge, either positive or negative. Here it's positive, plus 4. Number 2, state how the mass of the catalyst has changed, if at all, at the end of the experiment. So there won't be any change in the mass. So you write no change. The mass of the catalyst will not change. The mass will remain same. Only the physical state of the catalyst changes at the end of the reaction. Part D. Nitrogen monoxide gas NO and oxygen gas O2 reacts to produce nitrogen dioxide gas NO2 at room temperature. The reaction can reach equilibrium. The equation is shown. Here's the reaction. 2NO plus O2 gives 2NO gas, and the forward direction delta H is minus, which means it's exothermic. In the forward direction, it's exothermic. So in the backward direction, it's definitely endothermic. Delta H will be positive. So you write endothermic here. NO gas and O2 gas are passed into a beaker as shown in figure 5.3. Here's a beaker, 5.3. 1. Explain why the method shown in figure 5.3 will not allow the reaction to reach equilibrium. Definitely, it's not a closed system, it's an open system. For a reversible reaction reaching to dynamic equilibrium state, it must be in a closed system. Number 2, the apparatus is changed and the equilibrium is reached. The temperature of the equilibrium system is then increased and the position of equilibrium shifts to the left. Explain why the position of equilibrium shifts to the left. Definitely, if you look at the sign of the delta H, it's minus in the forward direction. And as I told you, if it's minus in the forward direction, which means it's exothermic, then backward direction, it will be endothermic. So definitely it will shift the equilibrium to the left hand side. So you can either write forward reaction is exothermic or reverse argument. Forward reaction is exothermic or reverse argument. Moving to the next part, which is part 3. The pressure of the equilibrium system is then increased. State the direction, if any, in which the position of equilibrium shift. Explain your answer. So they are increasing the pressure, which means it will move to the direction with less number of moles. Move in the direction with less moles. Remember, it's applicable to gases. The effect of pressure is only applicable to gases. So we have gases on both sides. And on the reactant side, we have 2 plus 1. On the product side, we have 2. What are these? These are the number of moles or molecules or volume of gases. Remember, the effect of pressure will be applicable to gases only. So it will definitely shift the equilibrium to the right hand side or forward direction. Forward or product side. So for the explanation, refer the number of moles, molecules, or volumes of gases. on either side of the equation, side of the reaction. So in this case, you are having less number of moles of volume of gases on the right hand side and high on the left hand side. Less product side or high reactant side. Moving to next question, which is the last question of this paper. Question number 6. This question is about hydrocarbons. A. State the meaning of the term hydrocarbons. Compounds which contain carbon and hydrogen only. Compound which contain hydrogen and carbon only. B. Propene. C3H6 can be made from long chain alkanes such as dodecane. Dodecane contains 12 carbon atoms. 1. Deduce the molecular formula of dodecane. So dodecane is an alkane. You know the general formula of alkane, CnH2n plus 2. You know the number of carbon atoms here. We have 12. So value of n is 12. So you write C12. 12 multiplied by 2 is 24. 24 plus 2 is 26. H26. This will be the final molecular formula of dodecane. Number 2. Name the type of reaction that occurs when long chain alkanes are converted into shorter chain alkenes. It's known as cracking. C. Propene is an unsaturated hydrocarbon. Propene reacts with bromine. Number 1. State the meaning of the term unsaturated. Contains at least one carbon-carbon double bond. Contains at least one carbon double bond. Part 2. Write the molecular formula of the product formed when propene reacts with bromine. So it's an addition reaction and you will get only one product. If you know the formula of propene is, it's an alkene. So it must be following the general formula of alkene, which is CnH2n. We have 3 carbon atoms here. So C3H6. And if you react with Br2, so what you'll do, you'll simply add this Br2 to this C3H6. So you'll getting C3H6Br2. This is alkene, it will undergo addition reaction. That's why you're getting this formula. Part D. Styrene molecule is represented as shown in figure 6.1. Here is styrene. Number 1, the molecular formula of styrene is C8H8. Determine the empirical formula of styrene. It's very easy. Simply have to simplify it. 8, same number. It will be divided by 8. So you will get CH as its empirical formula. Simplified formula means empirical formula means simplified version or simplest formula. Simplest formula. Simplest formula means simplest combining ratio. Number 2, styrene can be polymerized into polystyrene. State the type of polymerization that occurs when styrene is converted into polystyrene. You see the double bond is here. So it will definitely go for addition. Addition, polymerization. Last part. Draw the structure of one repeat unit of polystyrene. Include all of the atoms and all of the bonds. the C6H5 group should be represented as C6H5. So it's very easy. You simply have to remove the double bond. So all the bonds become single, and C6H5 will remain like this. And this will be the one repeat unit. They ask you to show only one repeat unit. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.